Okay, guys. So as I have said, that matrix is a very strong tool of solving system of linear equations. Okay. So here you can see there are three different equations given in terms of three different variables. All right. By using matrix method, we can very easily find out the values of the variables x, y, and z. So I'm going to show you how we do it normally. So as we see that, there are three equations given here. The first thing we need to do is just find out what are the coefficient of the variables. Here the coefficient of x is 1, coefficient of y is 1, plus 1, okay. Consider the signs also. Coefficient of z is plus 1. Then what is the coefficient of x here? There is no x, so there is a 0. So you can write as 0x plus, okay. So the coefficient of x is 0 here, coefficient of y is 2, coefficient of z is 5. Then here the coefficient of x is 2, coefficient of y is 5, and coefficient of z is minus 1. Okay. So we need to consider the coefficients of the given variables, and with that coefficient we will form a matrix. Okay. And we will name it as, say, A. So let A be the matrix of the coefficients of the variables. Therefore, A will be equal to, we'll get 1, then 1, and then 1. After that, 0, 2, and 5. Finally, we'll get 2, 5, minus 1. Clear? So this is nothing but the matrix of coefficients of the given variable, and we have named that particular matrix as A. Okay. Then also let capital X is equal to, capital X will be taken as a matrix, column matrix with the variables. So there are x, y, z variables. We are going to write x, y, and z. Okay. And B is equal to. Now we'll define another matrix which is called B, and B will be the matrix of the constants, which is 6 minus 4, 27. 6 minus 4, 27. Okay. Therefore, the given system of equations, okay, can be represented by matrices. By matrices as follows. So we can write like this, say the coefficient matrix first, which is 1, 1, 1, 0, 2, 5, and then 2, 5, minus 1. Okay, this when multiplied by x, y, z will give us 6 minus 4, 27. Now we know how to multiply matrix. In case of multiplication of matrix, first we multiply row into column. So if you multiply this to matrix, 1 into x, x, plus 1 into y, y, plus 1 into z, z. So we'll get x plus y plus z is equal to, on the right hand side, we have the first element 6. So if we equate, we'll get the first equation, x plus y plus z is equal to 6. Again, the next 0 into x, 0. 2 into y, 2y, plus 5 into z, 5z. And that will be equated to minus 4. So we are getting the second equation, 2y plus 5z is equal to minus 4. Finally, we'll get 2x plus 5y minus z is equal to 27, which is this. So the entire system of equations can be represented by matrix in this way. And this can be written as capital A for this, capital X for this, capital B for this. Okay. Therefore, X can be written as A inverse B. Now, this is very important for you to remember. Okay. So, when we have Ax equal to B, X will be equal to, when we take A that side, it is actually, since these are matrix, okay, it will not be plus minus, but it will be A inverse. A inverse into B will give you the matrix X. Now, we know how to calculate inverse. So, A is this matrix, the matrix of coefficient. So, we will first calculate the inverse of this matrix and then we multiply by B. Finally, we will equate with X. That is the step. So, let us start by finding the matrix inverse of this matrix A. This is the matrix given A. We have to find out the inverse of it. So, for inverse, what we have to do? Calculate the determinant, okay, then calculate the minors, then form the matrix equation, matrix with the, calculate the determinants, calculate the cofactors, then form a matrix with the cofactors. After that, take transpose of that matrix, you get adjoint A divided by determinant of A, you get the inverse. After getting the inverse, I will multiply with B. Okay, so let's start doing it. So, we are given A is this matrix. So, determinant of A is equal to 1 into 2, 5, 5 minus 1. After that, minus 1 into, again we will get 0, 5, 2, minus 1. After that, we get plus 1 is equal to, so we are left with 0, 2, and then 2, 5. Okay. So, that way we will get minus 2, minus 25. Here minus, we are going to get 0, minus 10. Then we will get plus 0, minus 4. So, that way we will get minus 27 plus 10 minus 4, which is equal to minus 17 minus 4, that is equal to minus 21. Okay, minus 27 plus 10 will be minus 17, minus 17 minus 4 is going to give you minus 21. So, determinant A is minus 71. So, we got the determinant which is not equal to 0, done. What is the next step? The next step is that we have to find out the cofactors of all these elements. So, let us find out cofactors of all these elements. So, let me start doing it here. Now, A11 will be minus 1 to the power 1 plus 1 and then minor of 2, 5, 5 minus 1. How much will be this? This is minus 2, minus 25, minus 27. A12 will be minus 1 to the power 1 plus 2 and then the minor 0, 5, 2, minus 1. Minus, we will get 0, minus 10, plus 10. A13 will be minus 1 to the power 1 plus 3 and then 0, 2, 2, 5, which is equal to, this is positive, this is minus 4. Then we have A21, 2 plus 1. So, A21 is this element. So, we will get 1, 1, 5, minus 1, which is minus of, that is minus 1, minus 5, 6. A22 will be minus 1 to the power 2 plus 2 and then the minor 1, 1 and 1, 1 and 2 and minus 1. So, that way we will get minus 1, minus 2, minus 3. A23, 2 plus 3, then the minor. So, it will be 1, 1, 2, 5. minus, and then that's 5 minus 2, that is 3. A 3 1, 3 plus 1, and then the minor will be 1 1 2 5. This is also same. 1 1 2 5. Yeah, 1 1 2 5. So this will be equal to 5 minus 2 plus 3. A 3 2, 3 plus 2, and the minor 1 1 0 5. That way we will get negative for here, 5 for there, minus 5. And finally, A 3 3, minus 1 to the power 3 plus 3, and the minor will be 1 1 0 2. That is equal to just 2. So these are all the 9 cofactors: A11, A12, A13, A21, A22, A23, A31, A32, A33. Now we are going to form a matrix of the cofactors, and thereafter we will take the transpose and find out the adjoint of the matrix, and then divided by the determinant. Which is the determinant? This is the determinant, and that way we will be able to find out the A inverse. Once we get the A inverse, we will multiply with B. Okay. So let's proceed. Yeah. So now let's form the matrix of the cofactors. So we'll write, therefore, matrix of cofactors of A is equal to. So we'll start putting the value of A11, which is minus 27, then A12, which is 10. After that, A13, which is equal to minus 4. Then A21, A21's value is 6. A22's value is minus 3. A23's value is minus 3. A23 is minus 3. Okay. A31 is 3. A32 is minus 5. And A33 is 2. So that is the matrix of cofactors of A. Okay. Therefore, adjoint A. Adjoint A is just the transpose of this. Change the rows to columns or columns to rows. Okay. So we will get minus 27, 6, 3, 10, minus 3, minus 5, minus 4, minus 3, and 2. Now that is adjoint of A. So therefore, A inverse 1 by determinant of A into adjoint A. So that means 1 by, what is determinant of A? Determinant of A is minus 21. So we'll write minus 21 into adjoint A is minus 27, 6, 3, 10, minus 3, minus 5, minus 4, minus 3, and 2. That is A inverse. Okay. Now, how to find out X? X is A inverse into B. So this is our A inverse. This is our A inverse. See, I am not multiplying this with this now. Okay, I am just keeping it as it is, because first we will multiply the B with this. Finally, we will put minus 1 by 21 inside the brackets. Okay. So we write, therefore, X is equal to A inverse B. A inverse is this, minus 1 by 21 into minus 27, 6, 3, then 10, minus 3, minus 5, minus 4, minus 3, 2, into B. Okay. What is B? Where is B? B is this, 6 minus 4, 27. So we'll multiply 6 minus 4, 27. We will multiply. So now we know matrix multiplication. How do we multiply? Row into column, row into column, row into column. Okay. So when I multiply this row with the elements of the column and add, I'll get the first element. Then again, when I multiply this row into column, I'll get the next element. And this row into the column, I'll get the third element. So I'll get a column matrix now, because here the order is 3 by 3. Here the order is 3 by 1. So when I multiply the two matrices, I will get a 3 by 1 matrix. What is 3 by 1? 3 rows and 1 column. Okay, so let's do it. So we'll get minus 1 by 21 into. So we'll get minus 27 into 6. How much will that be? Minus 42. 162. Okay. Then again, plus sign. 6 into 4, minus 4, minus 24. Okay. Then a plus sign. Again, 3 into 27. That will give you 2181. So that's the first element that we have got. Next again, second row into the first column. So you are going to get 60. Okay. After that, plus 60 plus 12, then plus minus 5 into 27. You'll get minus 5, 135. And finally, minus 4 into 6 is minus 24. Plus sign. Minus 3 into minus 4 is 12. Plus sign. And then 2 into 27 is 54. Okay. So this is what we are going to get. So this is what we got. A inverse B, we have minus 1 by 21. And now we are going to calculate this. So I'm doing it here. So x is equal to, we are going to get minus 1 by 21 into, in the matrix notation, we have minus 162, then plus into minus, minus 24, after that plus 81. Then we have 60 plus 12, okay, and then plus into minus, minus 135. Finally, we have minus 24. Then we have plus 12 and we have plus 54. Okay, that's what we are going to get, 54. Correct. So that is equal to minus 1 upon 21. And now we have to calculate these numbers. I mean, we have to solve this number. So we are going to get, this will give you 6, 8. So 186 is what we are going to get. 4 plus 2 is 6, 6 2 is 8, 186. And if we subtract 81, so we are going to get 105. So this is minus 105. Okay. The next one, 60 plus 12 is 72. If we subtract from 135, we subtract 72, then we are going to get 3. And here we'll get 5. That's it. 53 is what, one sec. Sorry, 63. So we are going to get minus 63. Okay. And as far as this is concerned, we'll get minus 12 plus, so this will be 42. Yeah, 42 plus 12 will give us 54. Correct. So this is what we are going to get. Now I'm going to multiply minus 1 by 21 with all those elements. So how much will I get? If I multiply, we will get plus 105 by 21. Then we'll get plus 63 by 21. And also we will get minus 42 by 21. That will give you how much? We are going to get 5. This will be 3. This will be minus 2. What is this? X. So we got x equal to this one. But what was the x? X was this matrix. So in place of x, we can write x, y, z is equal to 5, 3, minus 2. Okay. So when you have x, y, z is equal to 5, 3, minus 2, that means x is equal to 5, y is equal to 3, z is equal to minus 2. So you can write, therefore, x is equal to 5, y is equal to 3, z is equal to minus 2. These are the answers. So what did we do? Let's do a recap. We had a system of equation, number one. So we have formed a matrix by taking the coefficients of these variables. And that matrix has been named as A. Okay. And then we took the variables as a column matrix. We named it as X. And we took the constants as a column matrix and we named it as B. So our entire matrix or our entire equation changed into a matrix like this, AX equal to B. So from here we get X is equal to A inverse B. Then first thing is we need to calculate the inverse of the given matrix. So A we know, A is the matrix of the coefficient of the given variables. So we found the A inverse by finding determinant, by finding matrix of cofactors, then finding the transpose. So we got adjoint A and then we got the inverse. So this is the inverse matrix. Okay. After getting the inverse matrix, what we did, we put the value here. X is equal to A inverse B. In place of A inverse, we have put this matrix. In place of B, we have put the constant matrix, which is 6 minus 4, 27. So then we have used matrix multiplication. Since this is a 3 by 3 matrix and this is a 3 by 1 matrix, so the product matrix will be a 3 by 1 matrix. So we calculated and we found these three values. We got minus 105, minus 63, 42. So each of these values is now multiplied with minus 1 upon 21. So that we got this. Finally, we got 5, 3, minus 2. Now, what is on the left hand side? X, capital X, because X is equal to A inverse B. We got these values by doing A inverse B. So X is equal to 5, 3, minus 2. X is now substituted by the actual matrix, which is X, Y, Z. And when two matrices are equal, the definition says each and every element should be equal. Corresponding element should be equal. So since X, Y, Z is equal to 5, 3, minus 2, so we have X is equal to 5, we have Y is equal to 3, and we have Z is equal to minus 2. So that is the way how matrix equation can be solved. These are lengthy steps, not tricky sums, not difficult sums. But the steps are lengthy because there are a lot of things you have to do. First, you find out the matrix of coefficients, then you name it as A, and then you form the matrix equation, which is Ax equal to B. After that, you get X is equal to A inverse B. Then you follow the steps to find out the inverse of the matrix. Finally, you multiply A inverse and B and then equate it with X, put the X's matrix, and then you get X's value, Y's value, and Z's value. This is the way how we can apply matrix in order to solve a given set of or a given system of linear equations. Well, friends, that brings to the end of the unit 5, which is your matrix algebra. In fact, we have completed all the 4 units which is there in business mathematics. It was wonderful having a virtual journey with all of you, taking you through all the units. And I hope that I have been able to clarify your doubts. Keep practicing and keep scoring high marks in this particular subject. It's a very interesting subject. Thank you very much. Here I am signing off.